In today's tutorial, we are looking at percent error. Now, percent error is looking at the relationship between an experimental value and an actual value. I like to think of the experimental value as something that you are doing, an actual value being that you got it from a textbook or it was given in a problem. So to calculate error, we're going to look at the absolute value of the difference of our experimental from our problem, or what we found in our lab, minus our actual value. Now, notice how we have these absolute values. Don't forget that absolute value means that you will not have any negatives. Meaning when we eventually get to percent error, we're not going to have any negative percents. Now, percent error is going to be our error, which we just calculated on top, over the accepted or actual value. Your textbook or your teacher may have you as accepted or actual value. Now, to make it into a percent, we're going to multiply it times 100%. Now, you might also want to just substitute your error right in here and do it all as one step. So now let's try a problem. A student calculates an object's density as 1.40 grams per milliliter. The accepted value for this object is 1.30 grams per milliliter. What is the percent error? So first things first, you want to make sure that you know your experimental versus your accepted or actual. So a student calculates, that's going to be our experimental value. So we're going to write E is equal to 1.40 gram per milliliter. Our accepted value, as it says in the problem, is equal to 1.30 grams per milliliter. Now we're going to look to calculate the percent error. So first I'm going to calculate the error right here. Absolute value of our E minus our A. So our E is 1.40 minus our A, 1.30. So our error is equal to 0.10. Now our rules of sig figs go by addition and subtraction is by the lowest amount of decimal places. You'll notice they both have 2 decimal places, so our answer also has to have 2 decimal places. Now let's calculate our percent error. So percent error is going to be equal to that error, 0.10, over our accepted value. Now that still has a unit of grams per milliliter. Our accepted or actual value was 1.30 grams per milliliter. So we're going to see our density units cancel out. And then we multiply this times 100. So in our calculator, we want to do 0.1 divided by 1.3, and we're going to get this number. Now this isn't our percent error yet. We want to multiply it times 100. Now, since we divided and multiplied, we're going to go by the lowest number of sig figs. We have 2 sig figs here, and we have 3 sig figs here. So our lower one is our 2 sig figs. Now our answer says 7.692. We're going to go to 2 sig figs, 1, 2, and we're going to round up because it's a 9. So it's going to be 7.7% error. The larger number of your percent means the greater margin of error. Now we could already tell that he wasn't off by much in his calculation. And this